Good morning, class. Our lesson for today is all about mathematical language and symbols. Mathematics as a language has symbols to express a formula or to present a constant. It has a syntax to make the expression well formed, to make the characters and symbols clear and valid, that do not violate the rules. Mathematical symbols can designate numbers, variables, operations, functions, brackets, punctuation, and groupings to help determine order of operations and other aspects of logical syntax. A mathematical concept is independent of symbols chosen to present it. In short, convention dictates the meaning. Mathematical language is designed for numbers, sets, functions, operations, just like addition, subtraction, multiplication, and division. In these chapters, we will study mathematical language and its characteristics, convention of mathematical language, and mathematical symbols. We will also dealing with difference between mathematical expression and mathematical sentence. Characteristics of mathematical language. The language of mathematics makes it easy to express the kinds of symbols, syntax, and rules that mathematicians like to do and characterized by the following. First, precise. Precise, it means able to make fine distinctions based on definition. Example, a square is different to a circle based on definition. That is precise. Next, concise. Concise is able to say things briefly. Example, the long English sentence can be shortened using mathematical symbols like this. 8 plus 2 equals 10. In mathematical symbols is 8 plus 2 equals 10. That is concise, or they explain briefly. Next and last one is powerful. Powerful is able to express complex thoughts with relative ease. Example, the application of critical thinking and problem-solving skill requires comprehension, analysis, and reasoning to obtain the correct solution.
Mathematical language as an expression or mathematical expression is a finite combination of symbols, numbers, and letters that is well formed according to the rules that depend on that context. So finite, when we say finite, there is a limitation or meron siyang hangganan. Combination of symbols, so numbers and letters. In algebra, we called it constant and variables with the use of different rules. When we say rules, it includes expression. And a mathematical expression is a mathematical object of interest only. It's a correct arrangement of mathematical symbols used to represent a mathematical object, and take note of this. It does not make sense to us if an expression is true or false because it doesn't need to be. Because in mathematical expression, you cannot ask if it is true or false because there is no answer. For instance, of expression are here. So for example, 1 plus 2. This is just a mathematical expression. Can you ask if it is true or false? No, we cannot. Because there is no answer. 2 or rather 1 plus 2, true or false? No, there's no answer. So also here and here, these are all example of expression. An ordered pair in the Cartesian plane is an expression. You cannot do anything with 5, 6, 3, 4, and 1 and 2. There's no answer if it's either true or false. And so on. Matrix, likewise. A function, likewise. A set, likewise. It will not answer you if it is true or false. And there's no sense in asking that.
As a mathematical sentence, the explanation about mathematical expression was a incomplete thought. The mathematical sentence consists of different expressions. There are also operations, but there are additional symbols for equality or inequality, meaning there are two sides of equations that are related to each other. So there is a complete thought. Our example is 1 plus 3 equals 4. Because we have already put equals 4, so this thought is complete and it is also a mathematical sentence. x over 2 must be greater than x minus 4. It means that is already a complete thought because we all know the procedure on where to compare the x over 2. Also 4 plus 7, quantity 4 plus 7 squared is less than or equal to 49. So it completely thought. We can say that this is already a mathematical sentence. As if they were symbols of equality and equality, they serve as verbs in English or action words that relate to the two parts of the sentence, which is the first mathematical expression and the second mathematical expression. Since mathematical sentences have complete thought, it can either be true or false. For example, the sentence 1 plus 2 equals 3 is true. The sentence 1 plus 2 equals 4, in this case, this is not true or simply false. That is mathematical sentence.
A mathematical convention is the fact, name, notation, or usage which is generally agreed upon by mathematicians. So for instance, the fact that one evaluates multiplications before addition in the expression 2 plus 3 times 4 is merely conventional. There's nothing inherently significant about the order of operations. So mathematicians abide by convention in order to allow other mathematicians to understand what they write without constantly having to redefine basic terms. So imagine if every mathematical paper began with an explanation of PEMDAS. What is the purpose of mathematical convention? So conventions account for the choices of the mathematics community regarding the way concepts are defined, named, and symbolized. So what is the difference between a convention in a law and math? So although different conventions give us a different result, the interpretation is same. On the other hand, law is a set of rules that we apply on a set of observations, which are always the same under the same condition. So here are the examples of the basic algebra conventions. They add up many of the same variable, count the number of times that variable appears, and then attach the number called a coefficient to that variable. So like x plus x plus x plus x plus x equals 5x.
The different symbol in mathematical convention. There are 15 symbols. First is addition, subtraction, multiplication, two types of division, pi, infinite, equals, approximately equal to, not equal to, less than or equal to, greater than or equal to, square root or radical, degree, and therefore. There are the examples. 3 plus 7 equals 10. 5 minus 2 equals 3. 4 times 3 equals 12. 20 divided by 5 equals 4. A equals pi r squared. Infinite is endless. 1 plus 1 equals 2. Pi equals 3.14. Pi is not equal to 2. 2 less than 3. 5 greater than 1. Square root of 4 equals 2. 20 degree. A equals B, therefore B equals A. That's all, and thank you.
That's about the mathematical expression, which is BODMAS and PEMDAS. BODMAS means order, bracket, division and multiplication, addition and subtraction. And PEMDAS means parenthesis, exponents, division and multiplication, addition and subtraction. Actually, they are both similar. And I'll give you the example of this expression. Evaluate. Close and open parenthesis, 15 minus 5 times 10 plus 20 divided by 2. First, simplify first the parenthesis, which is 15 minus 5 is equals to 10. So the result is 10 times 10 plus 20 divided by 2. And now, since there is no exponent, let's proceed to division. So the division is 10 times 10. So 20 divided by 2 is equals to 10. So the result is 100. The result is 10 times 10 plus 10. And let's move on to multiplication. So 10 times 10 is equals to 100 plus 10. So the result is 110.